Do you know how to organize data using frequency distributions? Or do you know how to represent data and frequency distributions graphically using histograms, frequency polygons, or algebras? Let us provide you an in-depth understanding of these learning areas. So without any further ado, let's start the discussion. Sit back, listen, and enjoy the learning. So this video, we're going to show you about the frequency distributions and graphs. We're going to organize data using frequency distributions and represent data in frequency distributions graphically using histograms, frequency polygons, and algebras. So but first, what is organizing data? So when the data are collected in original form, they are called raw data. And when the raw data is organized into a frequency distribution, the frequency will be the number of values in a specific class of distribution. So now, what is a frequency distribution? So a frequency distribution is the organizing of raw data in a table form using classes and frequencies. So there are three types of frequency distribution: categorical frequency distributions, ungroup frequency distributions, and group frequency distributions. When we say a categorical frequency distributions, it can be used for data that can be placed in a specific categories, such as nominal or ordinal level data. On the other hand, ungroup frequency distributions can be used for data that can be enumerated and when the range of values in the dataset is not large. While group of frequency distributions can be used when the range of values in the dataset is very large. The data must be grouped into classes that are more than one unit in width. So there are terms associated with the group frequency distribution. The first one is the class limits. So class limits represent the smallest and largest data values that can be included in a class. The second one is the class boundaries. So the class boundaries are used to separate the classes so that there are no gaps in the frequency distribution. Then the class width. So the class width for a class in a frequency distribution is found by subtracting the lower or the upper class limit of one class minus the lower or upper class limit of the previous class. So there are guidelines for constructing a frequency distribution. First, there should be enough classes, between 5 to 30 classes. Next, it is preferable, but not necessary that the class width should be an odd number. The classes must be mutually exclusive. The classes must be continuous. The classes must be exhaustive, and the class must be unequal in width. So now let's go to the procedure for constructing a group frequency distribution. There are 8 steps for constructing a group frequency distribution. First, find the highest and lowest value. Second, find the range. Third, select the number of classes desired. Fourth, find the width by dividing the range by the number of classes and rounding up. The fifth one, select the starting point, and usually the lowest value, and add the width to get the lower limits. And the sixth one, find the upper class limits. The next one, find the boundaries. And lastly, tally the data, find the frequencies, and find the cumulative frequency. To better understand, let us have an example. In a survey of 25 students in BS Ed Math 2 who took the Advanced Algebra exam, the following data were obtained. Each value represents the scores of those students who were asked about their scores in the algebra examination. Since we have already data, now let's go to the 8 steps in constructing a group frequency distribution. So step 1, we need to find the highest and lowest value. So based on our data, our highest value is 39 and our lowest value is 26. Now in step 2. So in step 2, we need to find the range. So how to find our range? So in finding a range, we just need to subtract the lowest value from the highest value. So our highest value is 39 minus the lowest value, which is 26. So our range is 13. So in step 3. In step 3, we need to select the number of classes desired or denoted letter K. So we have a formula for that. The formula for the K is equals the square root of n, where n is the sample size. So based on our data, we have 25 students. So our desired classes will be the square root of 25, and that is 5. So now in step 4. So in step 4, we need to find the width. So how to find the width? So in finding the width, we just need to divide the range by the number of classes and rounding up. So we have a range which is 13, and our desired classes which is 5. So 13 divided by 5 is 2.6, and we need to round up. And 2.6 will become 3. So now we have a with 3. So now let's go to step 5. So in step 5, we need to select a starting point. So usually, the starting point is the lowest value. So based on our data, our lowest value is 26. So 26 is our starting point. So in order to get the next lower limit, we just need to add our width to our starting point, in which the 26. So the next lower limit will be 26 plus 3 equals to 29, and so on. Now we are on step 6. So in step 6, we need to find the upper class limits. Alright? So in finding the upper class limits, we need to subtract 1 from the width and add it to our starting point. And that is 3 minus 1 is equals to 2 plus 26. So we have the upper class limit, 28. The same as in the starting point, to find the next upper limit, we just need to add our width. So we have 28 plus width, which is 3, and that is 31. So on and so forth. So now let's go to step 7. So in step 7, we need to find the boundaries. So in finding the boundaries, we just need to subtract 0.5 from our lower limits and add 0.5 to our upper limits. So just like from our data, we have a lower limit which is 26. Subtract the 0.5 and that will become 25.5. And our upper limit, we have 28. So we just need to add 0.5 and that will become 28.5. So now, we have a class boundaries 25.5 and 28.5. So the same to the next lower limits and upper limits. So always remember, for lower limits, you need to subtract 0.5, but in an upper limit, we need to add 0.5. So now, let's go to the last step, which is the step 8. So in step 8, we need to tally the data. So first, we have 26, 28, 29, 31, 32, 34, 35, 37, and 38, and 40. So next, the frequency. So in frequency, as we can see from our data, so in frequency, 26 to 28. So how many times the 26 to 28 appear? So from our data, the 26 and 28 appear 4 times. The same as 29 to 31, 32 to 34, 4 times, 35 to 37, 3, and 38 to 40, 5. So always remember, in frequency, we just need to look at our data and find or look on how many times the data appear. So now let's also tally the class boundaries. So just like what I have said earlier, that in finding the class boundaries, we just need to subtract 0.5 from our lower limit and add 0.5 to our upper limit. So based from our data, our lower limits are 26, 29, 32, 35, and 38. So subtract 0.5 each, so 26 become 25.5, 29 become 28.5, 32 become 31.5, 35 become 38.5, and 38 minus 0.5, that will become 37.5. So in our upper limit, we have 28, 31, 34, 37, and 40. So in finding that, we just need to add 0.5. So 28 become 28.5. The same with 31 become 31.5, 34 become 34.5, 37 become 37.5, and lastly the 40 become 40.5. So now let's proceed to cumulative frequencies. So we have two cumulative frequencies. So first, the greater than cumulative frequency, and second, the less than cumulative frequency. So in finding the cumulative frequency, we need to add first our frequency. So based from our data, our total frequency is 25. So in finding the greater than cumulative frequency, we just need to put first 25. And 25, that is the total number of our frequency. So the next step is that 25 minus 4 from our frequency, that is 21, right? So 21, the same as minus 9, and that is 12. So 12 minus 4, that is 8. 8 minus 3, and that is 5. So in less than cumulative frequency, we need to start from the lower, in which we need to put first the 25 in the lower, and 25 minus 5 from our frequency, that is 20. And the same as 20 minus 3 is 17, 17 minus 4 is 13, and 13 minus 9 is 4. So now we're done with cumulative frequency, the greater than and the less than. Now let's go to the class midpoints. So we just need to add the lower limit and our upper limit and divide it by 2. So our first lower limit is 26 and our upper limit is 28. So 26 plus 28 is equals to 54 divided by 2. So that is 27. So our first class midpoints is 27. So the same as the next lower and upper limits, which is 29 plus 31 divided by 2, and that is 60 divided by 2, and is equals to 30. So the next one is 32 plus 34 divided by 2 is equals to 66 divided by 2 is equals to 33. So the next one, 35 plus 37 divided by 2, and that's to 36. So lastly, we have 38 plus 40, and that is 78 divided by 2, that is 39. So we have now our class midpoints, which is 27, 30, 33, 36, and 39. So there are three most commonly used graphs: histogram, frequency polygon, and cumulative frequency graph or an ogive.
An ogive graph is a type of line graph that displays cumulative data. In simple words, it shows how many things are less than, greater than, or equal to a certain value. It's often used in statistics to see how data is distributed and can help you find percentiles or understand the overall pattern of the data. So now, let us plot the data in the grouped frequency distribution table by creating an ogive. The data we need to make an ogive are the class boundaries and the cumulative frequency. The first thing to do is to draw a vertical line and then a horizontal line. The vertical line is for the cumulative frequency and the horizontal line is for the class boundaries. Now, let's get the cumulative frequencies, both the less than and the greater than cumulative frequencies, from the frequency distribution table. We now have the values 4, 13, 17, 20, 25, 21, 12, 8, and 5. The smallest value is 4 and the largest one is 25. Let us use the values from 3 to 27 and label each of them in the vertical line. For the class boundaries, we have 25.5, 28.5, 31.5, 34.5, 37.5, and 40.5. 25.5 as the smallest value and 40.5 as the largest. Now, let's label these values in the horizontal line, which are the class boundaries. So how do we plot the data? Before plotting the data, we have to first identify the types of cumulative frequency: the less than cumulative frequency and the greater than cumulative frequency. The first type to be plotted is the less than cumulative frequency. In plotting, let us start with the second least value of the class boundaries, which is 28.5. The less than cumulative frequency for the class boundaries 25.5 to 28.5 is 4. For 28.5 to 31.5 is 13. For 31.5 to 34.5, we have the cumulative frequency 17. For 34.5 to 37.5, we have 20. And for class boundaries 37.5 to 45.5 is 25. Let's connect the dots, then label it with less than cumulative frequency to identify it clearly. Next is plotting the data for greater than cumulative frequency. For 25.5 to 28.5 is 25, then 28.5 to 31.5 is 21, for 31.5 to 34.5 we have 12, for the class boundary 34.5 to 37.5 is the greater than cumulative frequency 8, and 37.5 to 40.5 we have the cumulative frequency 5. Again, connect the dots, then label it with greater than cumulative frequency to know what it is. Now that we are done creating the ogive, it is easy for us to identify the distribution of the data of the 25 students who were surveyed about their scores in the advanced algebra examination.
Going to make a histogram. But first, a histogram is a bar graph that represents a frequency distribution. The vertical represents the frequency and the horizontal represents the class midpoint. There are no spaces in making a histogram. A histogram is a distribution of data that is commonly used to visualize data distribution, identify patterns, and data analysis. Now, we're going to make a histogram. We all know that a vertical is our frequency. For our vertical or frequency, we're just going to put 2, 4, 6, 8, 10. And in our horizontal are 25.5, 28.5, 31.5, 34.5, 37.5, and 40.5. So, we all know the rule of making a histogram. There is no space. So, as you can see, the 25.5 and its frequency is 4. So, let's connect it to 28. And the 28.5, its frequency is 9, so it should be in the middle of 10 and 8. And in 31.5, its frequency is 4. So, we'll just have to look for its vertical and connect it to the next number, because in making a histogram, there is no space. So let's proceed to 34.5 to 37.5. And its frequency is 3, so it should be in the middle of 2 and 4. And in 37.5, its frequency is 5, so it should be in the middle of 4 and 6.
Hi everyone! So you already know what is histogram graph is, right? So today we will discuss about the other type of graph, which is frequency polygon. So do you have any idea what is frequency polygon? So frequency polygon, it is a graph, or it is similar to the histogram, but instead of using bars, it uses lines. So it displays the distribution of the data set. So in making frequency polygon, we will use frequency and the class midpoints. So now we'll make a frequency polygon based on the given data. So in making a frequency polygon, we will use the frequency and the class midpoint. So we can find the frequency in the second column and the class midpoints in the last column of the data. So first step in making the frequency polygon, so we'll make a vertical line, then a horizontal line, then the vertical line we'll label it with frequency, then in horizontal line we will label it with class midpoints. So we'll put numbers in the vertical line, so we'll put 2, 4, 6, 8, and 10. So in horizontal line, we'll put the class midpoints based on the data. So we'll put first 27, then 30, then 33, 36, and 39. So as you can see, we'll extend in the line of the horizontal line. Now, we'll plot points in the graph that we make. So in class midpoint, first 27. So the frequency is 4. So we'll put points here, line with 4 and 27. The class midpoint 30. The frequency is 9. So in between with 8 and 10. So we'll put here, line with 9 and 30. 30 is the class midpoint 33. So the frequency is 4. So the same with 27. So line with 4 and 23. So next is 36. So it has a frequency of 3. So in between with 2 and 4. So we'll put here. Then the class midpoint 39. So the frequency is 5. So we'll put the points here between 4 and 6. So next step is we'll connect the points. So from here, we'll connect to the first point, to the second point, to the third point, to the fourth point, to the fifth point, and lastly, fifth point to the horizontal line. So as you can see, this is how our frequency polygon looks like.